Not a ton of free info in this question, but we are told that x is a positive integer greater than 1. That's probably going to be important. It's not 1, it's greater than 1. What is it? That's it. That's all we know. I think I'll start with statement 2. It seems a lot easier to evaluate, right? Statement 2 tells us that x is a factor of 6. I know that it's not 1, but it could still be 2 or 3 or 6. 3 different values that are possible for x. We should eliminate the answer choices that claim that statement 2 is sufficient on its own. So B, D, gone. We're down to A, C, or E. Now, statement 1 is not talking about x, unfortunately. It's talking about 2x. But maybe we can take statement 1 and just reduce it by a factor of 2. So instead of reading it as 2x is a common factor of 18 and 24, we can read it as x is a common factor of 9 and 12. And remember, we know that x is not 1. It's a positive integer greater than 1. What are the common factors of 9 and 12? If this is hard for you, draw the prime boxes for those two numbers, right? 9, that's just 3 squared. 12, that's 2 squared, 3 to the power of 1. What do those boxes have in common? The prime box of 9 doesn't have any 2's, so there's no 2's in common. The prime box of 12 has a single 3. That's your common factor. That's it. That's all you have. So we know x is not 1. Well, it has to be 3. That's the only other common factor between 9 and 12. So statement 1 is sufficient on its own, and therefore the correct answer is A.
If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.